In this video, we are going to be looking at optics, precisely Neco practical on plane mirror. So I'll quickly read through the procedures and instructions. 1. Fix the drawing paper provided on the cello test board. 2. Place the plane mirror vertically along its breadth on the drawing paper. Trace its outline MN. Remove the mirror. Mark the middle B of the outline. Draw a normal AB to meet the outline at B. Draw another line XY through B such that it makes an angle theta equals 0 degrees at B. With the outline of the mirror, draw another line XY through B such that it makes an angle theta equals to 10 degrees at B with the outline of the mirror. Fix two pins P1 and P2 on AB. Replace the mirror on its outline. Rotate the mirror gently until it rests on the new line XY. Ensure the position of B on the outline is maintained. 6. Locate the images of P1 and P2 in the mirror. Locate the images P1 and P2 in the mirror. Fix two other pins P3 and P4 such that they appear to be on a straight line with the images of P1 and P2. 7. Remove the mirror and pins P3 and P4. Draw a line to join the pinholes of P3 and P4. Produce the line to meet MN at B as shown in the diagram. Measure and record phi. 10. Repeat the procedure for 4 other values of theta equals 15 degrees, 20 degrees, 25 degrees, and 30 degrees. In each case, measure and record the corresponding value of phi. 11. Tabulate your reading. Plot a graph with phi on the vertical axis and theta on the horizontal axis. Determine the slope S of the graph. State 2 precautions taken to obtain accurate result. Now in this video, like I did in my previous video, remember this is going to be the part 2 of the first video. I am going to carry out this experiment without actually using a plane mirror and also looking through the plane mirror. So what I'm going to do, I'm going to get my pin, my plain sheet of paper, and I'm going to use a pen so that the outlines will be very visible to you. So let's quickly draw out the layout and determine the position of theta and phi from our diagram. To draw the outline, what we need to do is to take any length for the measurement of the plane mirror. So let me take, for instance, let's take 8 cm. So I'll draw from here. That's 8 cm, and I take the midpoint. The midpoint is definitely 4. So from the midpoint, so this is the outline is M N M N. So I'm going to get the normal. To get the normal, just place this under this and ensure that this line here is always under 0. Or maybe if you can see the readings from the other side, this way. So we can just read directly from here. So I'm actually turning it upside down so that we can just read 10, 20, 30 from here. So this is 90. So this on 90 here. So that gives us the normal. So I'm going to draw a line through this. Whatever line I draw through this is going to be the normal. So this line is perpendicular to this. So this is my A and this is my B. So what I have to do is to rotate the mirror through 10 degrees. So I'll place this here. Let me turn this way so that we can actually read off these angles directly from here. So this is, so ensure that this line aligns with the 0 and the 180. So this is 10 degrees. So I'll put a dot there. Then I'll draw through B. Draw a line through B. Put a dot here. Okay, let's check it out. It's good enough. So I'll draw this through this. So I'll draw this through this. Now the next thing we have to do, we are supposed to put 2 pins here. Put 1 pin here, and at any other point just place them there, but we don't need that. Just remove it, because here I will not be using the plane mirror. So the next thing I have to do is to replace my protractor on this new line. Just place it on it like this, and also ensure that the 0 and the 180 mark are on this line. So now I'm going to obtain a new normal. So this is going to be my new normal. You can read it off there. The angle between this and this new normal must be equal. So if I read from the normal there, this is 10, 11. So I have to read 11 this way. So this is 10, this is 11. Do you understand what I've just done? This is my new normal. On rotating this, this normal is going to shift this way. So I'll just mark it out without putting a point there, because we are not required to show the new normal. But we are using it to get manipulated results for our practical. So this is my new normal. So I'll just count from the normal to this place. The angle between this and this is 11. Again, I'll count the angle from this to this point to be what? 11. So I'll just put a dot there. Then I'll draw a line through this. Now, the reason why I have done that is this. You know that we are placing our pins, pin P1 and P2 permanently at this point. So when we place the mirror here, we are going to have a reflection through this point on this mirror. So that is why I have done that. So this, you are going to get the new normal. The new normal, or the angle between the incident ray and the normal, must always be equal to the angle between the reflected ray and the normal. And remember that I marked my normal somewhere around this point. So this angle here must be equal to this angle here. So the next we have to do, okay, this is 10 degrees. So the next one, so this is my phi 1. So this angle is phi 1. That is what they asked us to determine. These angles here, phi 1. Now you already know what I already know what my phi 1 is. My phi 1 is 22, because remember that this angle from here to here is 22. So I'm going to write phi 1 is equal to 22 degrees. I'll tabulate that later. 22.0 degrees. That should be close to 20 degrees anyway, bearing all my measurement error and all that. Okay, so let's go for the next one, which is 15 degrees. So I'm going to place this on this again, on this, the first outline. Then I'm going to measure 15 degrees. So this is 15 degrees. So that's my 15 degrees. So the next thing I have to do is to draw a line through this. So when I draw a line through that, now I'm going to place this on the new line. Okay. So I'm placing this on the new line. Ensure that the 0 and the 180 are on this line. So this is my new normal. This is my new normal. So from the normal, let me count this way. This is 10, 15. So I have to count 15 from the my new normal this way. So I have 10, 15. So I'll put a dot here. So I'll draw this from point B to this point. So this is my 5, 5, 2. So my 5, 2 is definitely going to be, because I counted 15 this way and it's going to be 30 degrees. So my phi 2, let me record that phi 2 equals 30.0 degrees. Let me do this back this way. Now if you look at what we have done from the first two, you find out that it is actually, when we rotate an angle, a mirror, the reflected ray is rotated by 2 theta. So let's go to the next one. So we have 20 degrees. So from the first outline, place this on this. Okay. So I'm placing this on this. So I'm going to measure .20 degrees. So this is 20 degrees. So I'm going to place this here. Just this a bit. And I'll draw this through this point. This was 15 degrees. And this one is 20 degrees. So again, I'm going to place it on the new line. So I'm going to place it on the new line. Ensure the 0 and the 180 are correctly on that line. So let's measure this. This is, okay, let me adjust this a bit. So this is my new normal here. So I'll just count it this way. This is 10, 20, 21. So I'm going to count from this way now. This is 10, 20, 21. This point here. So I'm going to draw this again. So this is phi 3. So you already know what this angle is. I'll just multiply what I counted here by 2. That's 21 times 2. That'll give us 42. So my phi 3 is equal to 42.0 degrees. It's okay to have all those errors. It's supposed to give us 40 degrees, 20 times 20, times 2 rather, but it's okay. Then the next one is 25 degrees. So I'll go to the first line. So I'm going to measure .25 degrees. Okay. That line must be on 80 and 0. So I'm going to measure 25 degrees. This is my 25 degrees. So on my 25 degrees, I'll go this way. Place this here. Let's see. Okay, we can draw through this. So I'm drawing through that. So place this on top of this again on the new line. Adjust until this rests on 0 and 180. Okay, on this line. So my new normal is this. So I just count for my new normal this way. This is 10. This is 10. This is 20. This is 25. 25.5. So I'm going 25.5 this way. This is 10. This is 20. 25.5. So I'll put my dot there. So I'm going to draw this. Through this. So definitely my 5/4 is going to be 21.5 times 25.5 times 2. So that's going to give me a 51. So my 5/4 is equal to 51.0 degrees. Normally we are supposed to have 50 degrees, but it's okay to have all this measurement error. You cannot be that perfect with your measurement. In fact, when you do that, the examiner will already know that you are doing some manipulation. So let's go to the next one. 30 degrees, that's the last one. So on the first outline again, so on the first outline I get 30 degrees. So this is my 30 degrees. Okay, it's my 30 degrees here. And I'll measure it, I'll draw it from this point. So I'll place this on top of this again, the new outline, put at the center. I'll have 0 on the 0 mark and on the 180 mark. So my new normal is at this point here. So let me count. This is 10. This is 10. This is my new normal here. Here. So this is 10, 20, 30. So I'll go 30 this way. From here, this is 10, 20, 30. So I'll put it here. So I'll draw this. I'm going to draw this from here. So this is 5/4. Now the next thing you have to do is to get your needle, your pin rather, your optical pin, and make some points on the rotated mirror. Just put one pin here, put another one here. Of course, we want to have pins for this. This is for the incident ray, this is for the reflected ray. So I put a pin here. You can put it anywhere. I'm only putting it here because I already have point holes here. So I put one here. I can even put one this way, put one here, and put one this way, put one here, and put one, let's say, here. So we are good to go. So this is the outline. So you can submit this outline. I decided to use a pen because I want the outline to be visible to you. So the next we have to do is to plot the graph. So we have to plot the graph of theta against phi. In fact, let me first of all bring out the composite table that I have for this. So this is my composite table. Of course, the other angle, because I measured 30 on the other side and the other side, so I had 60.0 degrees. Like I said earlier, on the norms, this is supposed to be 20 degrees, 30, 40, 50, and 60. But because we are carrying out experiment and there are measurement error, it's okay to go for this. In fact, the slope of this graph is supposed to give us 2, the factor that we are multiplying the angles theta with 2. So let us draw the graph by plotting the graph of phi on the vertical axis and theta on the horizontal axis. So let's choose appropriate scale for our values. Here I have this on the horizontal axis. So if I have 10, 15, 20, 25, 30 on the horizontal axis, so I can easily go 10, 15, 20, and 30. I think that will be enough. 10. So if I take this to be 0, 10, 15, 20, 25. So it's not going to be enough. So I can go with 10, 20, and 30. So let me go with this. So I have 10, 20, 30, 40. So obviously I am going to have I can put 5 this way, 15, 25. So we can go this way, 5, 10, 15, 20, 25, 30, 35. So this side is theta in degrees. Then I'm going to get the vertical axis. So we have the scale. So our scale is going to be 2 cm to 5 degrees. So this is my scale on the theta axis, 2 cm to 5 degrees. So we have to look at the vertical axis. So I have 22, 30, 42, 51, 60. So I can easily go 2 cm to 10 degrees. So I have 20, 30, 40, 50, 60, 70, 80, 90. So I'm going upward so that I'll be able to use a large chunk of my graph. By that I mean that I extended it beyond 60 to 90 so that I can have almost more than 2/3 of the space on my graph paper. So this axis is phi in degrees. So let's take the scale. Obviously this is 2 cm to 10 degrees. So on the phi axis we have 2 cm to 10 degrees. So we can now plot the point. So for the first one we have 10 degrees for theta and 22 degrees for 10 degrees for theta and 22 degrees for phi. So we can easily read this. This is 10, 20, 21, 22. So put a dot and draw a circle. The next is 15 degrees for 30. 15 degrees for 30. So I'll go 15. Put a dot. Then the next one is 20 degrees for 42. So I have 20, 41, 42. Put a dot here and draw a circle. The next is 25 for 51. So this is 25, 50, 51. Put a dot. And the next one is 30 for 60 degrees. So I have 30 for 60 degrees. So I have to determine my line of best fit for this. Okay, seem to have fit into all of them. So I can draw this. Okay, let me take a line of best fit for this. So I have this to draw this through any point and to any length. So it fits into all of them. Okay, so I'll take my slope. So my slope is delta phi, delta theta. So let me just calculate the slope here. My slope S equals phi 1. This is 71 degrees minus 20 degrees divided by, so I have 35 minus, this is 9. So this gives us 71 minus 20 is 51 divided by 35 minus 9 is 26. So when I divide that, my slope is going to be equal to 1 0.96, which is approximately equal to 2, which is our multiplying factor. So with this, because of our little measurement error here and there, it is not compulsory that we are going to have exactly 2, but we can have a value that when we approximate, we get to. So that is the slope of the graph, which is 2, because we are multiplying. This number is very close to 2. When you approximate this to this, it gives us what? Exactly what? 2. So don't forget to write the title of the graph. The title of the graph is phi in degrees against theta in degrees. So that's all for this video. Do not forget to subscribe, like, and share as usual. See you some other time.